Okay, so here we have a quick recap of how SQLite 3 works in Python. So as a reminder, I really want to emphasize on the structure of this diagram again. So a lot of the code, the SQL code you're writing, is actually not working in Python. So whenever you say, okay, there's a query, there's a command is embedded in the string, that usually means, okay, those queries, those commands are SQL commands. And they're not executed by Python, but they're executed by your SQL database. What it's doing is that, okay, whenever you're calling the cursor is going to tell your computer, okay, I need to send this request to SQL, and SQL will execute those requests for me. We do this for a good reason because, well, usually SQL is written in a lot more performant languages. It runs a lot faster than Python. It has a lot of built-in ability that pandas or Python in general just don't have. As a result, we're just sending, okay, this is not a good idea to run this in Python. We're just sending those things to the SQL databases. And once I got my results back, I could use those results in Python. That's how this thing works behind the hook. And we have seen this type of basic architecture and the basic components we need to know from last week. We have a database, we have the SQLite files. These are where your SQL is. Well, I think it should be corrected. We're not using SQLite files. .SQL file. This is kind of like a CSV or other type of files that's actually working with a database. And your connection is just trying to send your request to those areas, etc., etc. And we have also seen some basic SQL queries last week. We have seen select from, where, order. Hopefully you think this is a little bit more natural. And it's supposed to be a little bit more natural than pandas in many sense. Okay, we have also investigated and worked with a little bit with join, aggregation, and halving, and kind of the last bit of my session last week. And today we're trying to start from here and building on top of these concepts and try to explore a little bit more those ideas. We're going to use the Seattle Airbnb open data from Kaggle for this session. If you're interested in where this comes from, it's here. Fun fact, this is actually kind of like an extended work or professional version of what you're going to do next week. So next week, you're going to see web scraping, which means that you're basically trying to write a Python code to extract the data from the internet and save them. And this data set is actually collected in the same format in that manner. It's a huge, well, not huge, but like a more tasteful work of web scraping. It's really scraped from, okay, I have Airbnb website open, I have a Python code ready. What do? I just keep scraping the data down so that I have my own Airbnb data set. What can I do with it? Well, if I am Airbnb's competitor, I could run this analysis and say, okay, can I price out Airbnb? Or if I'm a regulator, I could set, hold on, you guys are doing something fishy based on the data we have from your website, something like that. So it's really up to you. And also you could run, if you know how to do web scraping, you can run a lot of things if you're interested in doing that. Anyway, so these are just for setting up the data sets. Don't really do a lot other than setting up the things so that we can run the code here. You do need to run these things if you want to run this notebook. So let's see. Ultimately, we have three different tables. We have a calendar table, we have the listings table, we have the reviews table. The calendars table basically has the listing ID, like maybe one of the hotel, maybe one of the Airbnb you can see on the website, for one of the day, whether it's available or not, and the price. And I think you have like a million or so records in this table. The next table we have is the listing table, which is the information about this listing. This is a very lengthy table. We're not going to use a lot of this, but this is basically all the information you can find about this Airbnb online. You should be able to find this in this table. The name, the summary, the space, the description, blah, 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 blah. Feel free to dive into this if you're interested. We're not we're not using a lot of this table, but I think maybe some of these things will be dead. Like maybe they reroute their URL, so you're no longer able to use that. Some of them might still be alive, but you could give it a try. I think this data is almost 10 years, so my suspicion is that a lot of these listings will be not working. Okay, we also have the review table where basically, okay, if someone has ever left a review to this Airbnb, this is the listing ID, this is the same ID as in the listings table. This listing ID is the same ID. Well, it's kind of a terrible practice. They're not using listing ID here, it's just ID. But this is supposedly what we call the foreign key, where you're referencing the key in a different table. Okay, we have the review ID. This is the ID for this particular review, the time this review is left, and who is this reviewer? It could be tracked down to one of the account or whatsoever, and reviewer name. Okay, this is this is some of the data set you're going to look in real life if you're working as a data analyst, data engineer, or whatever. Could look like a medium or small size data sets you're going to work with in real life. And this is the data we're going to use for today. So first, let's try this warm-up question. Now I want to do the following. For each of the listing, I want to find the number of reviews they have in the review table, and which of them correctly do this. So for example, I have this listing 241032, right? And I could find their review based on their listing ID in this table. Yes, I want to know how many reviews does each listing has. How can I do this? We have three options, and I'm going to give you a couple minutes to think. This is a little bit more complicated. So yeah, all of them are very similar except for some tiny differences. And all of them are executable. You can execute all three of them. But their logic is a little bit different. So L.id is your listing ID, and this is counting the R.id, so counting the reviews. Okay, all of them are doing this thing. From listing L, I'm selecting from one of the table, and if I need information from another table, I need to use join. Okay, A and B are using left join, but C is using inner join. Does that matter? I'm not going to tell you the answer now. And then you're grouped by L.id. Okay, this one is grouped by R.id. Does that matter? And finally, they're ordered by review count. So which one of them is the right operations we want? I want for each of the listing the number of reviews I have, right? Actually, I can even do this easier. I don't even need to join this, but whatever. Oh, I want to join this because I want to get the name of the listing as well. I think that was my original intention. Yes. This way I can have L and name. I should have this. But that doesn't really change the nature of this problem. So ultimately, I want the name, the listing ID, and the number of review each one of them has. So which one of them is the right one? Make your best educated guess if possible. I'll pause here for a couple seconds. I think I've walked through kind of how the query is run. Which of them is doing the right thing? Which one of them will have all of the listing ID? I want to make sure, okay, even if there's no review, I'm still getting if there's no review, my listing ID should still be there and my review count should be 0, right? So which one of them correctly do this? I want all of them to have, well, all of the listings. That's what I want to emphasize. And also, I want the right count. So, which one of them does the job? Pause here until someone try to make your best educated guess. B. Okay, I see one answer. Anyone else? I'm pretty sure we have more than one person here, so we should have more than one answer. Anyone else? Or everyone agrees B? We all agree it's B? If you agree it's B, then leave a +1 in the chat. +1? Okay, +1. Most of us agree it's B. Actually, let's run them one by one to see which one is kind of the answer we want. I don't think I can select. Fun fact, you can group by more than one thing. Oh, sorry, I didn't specify this should be SQL. Okay, this is the result. For each of we have 38. Wait, is this A or B? I can't remember, so I'll copy paste again. But I think there's a minor thing I need to fix here. Fun fact, for each of the columns you're not running an aggregation, you need to put them into group by. Otherwise, you'll get an error. So this is option A. Okay, for listing, I'll pause for now for the result. And this is option B. Again, I need to fix this tiny thing because I forget about it. Okay, they are looking very similar. But notice one thing. Option B has, why is there only one review count for each of them? Where it's supposedly 474. Huh, that's interesting. Let's see option C. Let's see. I don't think you can even run this. Oh, yes, I could. Again, hold on. I have 84,000 rows. Okay, someone changed their mind. So, yeah. C seems to be obviously wrong. I'm not supposed to have 84,000 rows. Now, what's the problem? Well, that's because I'm grouping by r.id. What is r.id? The review ID. This is the review ID. So I am not, instead of counting how many reviews I have, I'm counting how many times this review, because I'm doing the aggregation by the review ID. Well, when you group by and count the group, well, each group will exactly have one presence, right? I'm grouped by the review ID. Sorry, this is the review ID. So all of these things with the same ID will be merged into one row. That's intrinsically how group by works. So option C is wrong because we're using the wrong group by. This is the problem. That's what's wrong with option C. And another thing that's wrong is the inner join here. Inner join will make sure, okay, when it's both in the table, the final result will only contain the ID that's in both of the table. And, well, this is true, but remember, I want all of the records from the listing table, all of the listing ID from the listing table. So that's why this one is not the right one. This is also a wrong join. Let's see what's wrong with option B. Okay, was this option A or option B? What's wrong with this? Remember, what does L.ID equals to R.ID mean? That means my listing ID is the same as the reviewing ID. Does that make sense? This is a wrong join condition because, well, I'm not joining the right ID, right? The listing ID here, it's the ID in this listing table. So I'm supposed to join ID with the listing ID here, not the ID with this ID. Notice the difference? So this is the wrong joining condition. So only A gives out the final answer. And as you can see, it's very easy to fall into this pivot just because, well, the names are kind of similar. And yeah, it works, right? It runs. It could run doesn't mean it's the right one, unfortunately. And this is a very common type of mistakes in SQL. You execute the result and okay, this kind of looks fishy, but I don't know what's wrong. Yeah, there's something wrong in your logic here. So hopefully this will get better as we write more query, but please take into account exactly, okay, what am I joining? What is the joining condition? Is that correct? And what am I grouping by? Is that correct? Okay. I think that's more difficult than a warm-up exercise should be. But anyway, let's review a little bit of aggregation and halving. Okay, so I think I emphasized this last week that, okay, these things, count, sum, average, minimum, maximum, these things will collapse a lot of the record into one numbers, right? If I'm count, okay, how many numbers are in 1, 2, 3, 4, 5? The answer is 5. I'm converting something with from 5 number to 1 number. And the same goes for sum. The same goes for average, minimum, and maximum. There are a couple more of them. This is not everything you could do with aggregation. There are maybe 100 plus other aggregation functions. You could even define your own one if you want to. That being said, this is just to reiterate again, whenever you're trying to, you need to use a group by. Well, group by is not the only case you could use aggregation function. We are going to talk about window function today. But usually, these things need to be combined with group by. And the problem with group by is that, okay, it's kind of easy, right? Sometimes you don't even need a group by. You could still run this, or I can run max, but this will convert it to a number. The problem with aggregation is that, or I could run, let's see, r.id. Let's run it this way. And this is, well, I think this was supposedly used to check what is supposedly, well, how many listings do I have? I have 3,818 listings. So in my final, if my final records is right, I am supposed to have 3,800 listing ID. So this will eliminate immediately let me know C is wrong. And I could also run things like r the, let's see, listing ID count star or count. I think I should still count review ID. Well, doesn't matter. Count star, just like select star will count. Okay, how many times this listing ID appear from, let's say, reviews. So let's see. I'm not grouping by listing ID. From sorry. This is telling me, okay, this listing ID appeared in the review table 35 times. This listing ID appeared in the review table 297 times, and so on and so forth. Okay, so most of the time you need, well, if the principle is, yeah, in some cases you could have like one of the column that's not appearing in aggregation, but most of the time, like whenever you're selecting it in a group by statement, those columns that's not parsed into a aggregation function should appear in a group by statement. Otherwise, you're likely to get an error. It's either a syntax error or the code could still run, but you're getting a nonsense, depending on the SQL version you're using. Now, I want to reiterate again that where is executed before all the group by and aggregation. So if you want to filter the result by the aggregated values, you'll get an error. Let's take a look at this one. Some of you may have noticed why it's kind of like this. Okay, I have this listing ID. I want to know the maximum price and the minimum price of each of the Airbnb. I want to know if I'm overpaying or am I getting a lucky number. For example, if this listing is usually like $500 and I'm paying 2,000, I don't want to pay 2,000 for what is usually 500, right? And on the other hand, if I'm paying $200 and this is usually listed at 500, oh yes, that's great. And okay, we have a lot of non-result, but this seems okay. I think I need to rerun some of that. I think I already run the fixed version for some of the results. That's not supposed to happen. Yes, this is supposedly a demonstrating error. Okay, some of you may have noticed, oh, this min price is higher than the max price. I'll leave it here. Just let you think about why is this the case. But more importantly, when I try to run, okay, can I fix this? I think this is obviously wrong. I want to fix it by this clause. But it's telling me, no, you can't, by a syntax error. So how can I fix it? Can anyone suggest a way to fix it? Yeah, I want to filter by the condition, but this condition contains an aggregation function, so it's not working with where. So what could I do now? What could I do now? Can anyone tell me? Just shout it out loud or type in the chat. How can I fix this? Where is not working? Yes, because I have aggregation function. So what can I do now?
Where is the first? Yeah, executed before all the group by and aggregation.
Yes, where should be used before group by, so how can I fix it? How can I fix this statement?
Select from there, group by, order by?
That doesn't fix the problem, right? Because I try to finish this minimum price is greater than maximum price weird problem. I still want to filter this result somehow, but I can't use where. But there is another thing I could use. Having, someone pointed out. Just change it to having, right? Well, it's not running, but hold on. Why is this minimum price still greater than my maximum price? This doesn't make sense at all. Something's wrong with SQL, or something's wrong with my code. Well, actually, none of them is wrong. That's because, well, this has a dollar sign in it. This has a dollar sign in it. It's suggesting that, well, yeah, that's not working because you're comparing two strings, and one is smaller than 9. If it's something is a string, then it's comparing it string, character by character. 1 is smaller than 9, so 1099 is smaller than 99. So that's the problem. We're comparing two strings. We're not doing the right comparison. And the fundamental reason is that my price is a string, it's not a number. Okay. And I think this is probably a lot of you have seen this type of problem. You're basically comparing something like 3 and 3. That's the difference like this. If you're supposedly use an integer 3, but you're parsing it as string 3, well, sometimes your code could still run, but a lot of the cases you're getting an error. And that's exactly the same thing here. So in order to solve this problem, we need to know a little bit better about the SQLite data type. In SQLite, well, disclaimer, this for different version of SQL, you have different type of data type. SQLite has null, integer, real, text, bluff, and cast. Well, cast is not a data type, but cast is the one that you're using to cast around them. In PostgreSQL, you have null, yes. You have integer, yes. You don't have real. You have decimal or float. You have text, yes. Some other version of SQL is string. And some of them also have a specific type called date time. Just like PD, the to date time, you convert it into a datetime type, etc., etc. In SQLite, these are the basic ones we have. We don't really have a datetime type here in SQLite, even though we have functions for that, but those functions work with string. And so the fundamental question is, okay, I don't want a string, I don't want a text, and I want to make numeric comparison. So what can I do? Well, I want to convert them into either integers or real, right? So let's run this script again. Oh, I should run a limit because this one is taking longer because I have more than 1 million records. It's going to take a while. Disclaimer, if you later in your career, you might bump into something with millions or billions of records. Yes. For those one, running select star from something is a terrible idea because running that command could take hours, regardless of how good your computer is. If you could even still run that, you could take hours if you just run select star from something. So, but it's fine for millions, up to like million rows of data. So the solution for that is, well, this is a string. It's not ideal. So I am testing this thing when I'm running this. I cast it first into a real number. I cast it first into a real number and calculate my minimum price and maximum price. Voila! Now this is solved, right? Now I have a lot better result. And another way you could do it is use update and set the price directly. However, I have tested this solution. This seems to work well. However, I noticed that I'm not sure if it's a Python issue. Is it a Python issue or a SQLite issue? But this one will only convert part of the data set. It doesn't really convert everything. And in general, this is a bad command to execute. Why? Well, in general, if you're really working with a very serious database, you should not convert a data type halfway. What we should do is, before we read a database, we should run this create table statement. Create or replace or whatever, and then blah, 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 blah. We should run the create table and then specify the data type. Listing ID create. Let's just run this. It's not probably not right. Listings. And then something like select from. You could, well, this is a C test statement, but before that, you should try to run this, like enforce the schema of this table. Let's see if I can have, well, I don't want, you should try to specify, okay, listing ID as, let's say, integer, and then the, what is it, date as text, and so on and so forth. Before you read this table into the database, you should specify the schema for this data type, for its data type, instead of running this. This actually doesn't really work for this specific case. But anyway, now it seems the real reason this like first example is not working is really because it's not in the right type. We really need to convert them into real to prevent this type of problem. Okay? And typecasting is never going to be, well, you're always going to be worried about typecasting and issues whenever you're working with programming language. Put it that way. You're going to work with typecasting with Python sometimes. You're going to work with typecasting with SQL in a lot of cases. So keep this in mind. If you ever feel like, hold on, why is my comparison giving me nonsense? Chances are your type is not right. You might need to cast them into the right type, or your logic is just wrong in some case. Okay? And well, this is a very superficial introduction to typecasting. There are a lot more about what you could do with that. Feel free to take a look into them. Of course, it also depends on different version of SQL you're using. It's kind of not ideal, I get it, but yeah. So hopefully we'll get a better sense of how to run this type of stuff. Not sure if we have time to finish all of the materials today, but hopefully we do. So the next topic, I'll pause for a few seconds before we go into the next topic, subquery and common expression table. Any questions about typecasting? Nope. Okay. I would say a kind of final reminder that most challenging typecasting happens with string because you could have different formats. And it's kind of like, I think you can work with regex formats here with replace. You could work with regex format here when you're type like converting stuff. This one is going to what this one is doing is basically strip off the $sign here. And now once this is not without a $sign, I could cast it into a real number. That's easier. But in some other cases, when it's a date, when it's a time or whatever, it's a huge mess. Yeah, it's a huge mess. And I would admit it that usually having ChatGPT was whatever, writing those typecasting script for me is better. But ChatGPT is terrible in writing SQL query in some sense. It will give you a wrong query in many cases. Put it this way, ChatGPT will not help you catch what's the right result for these three queries because all three of them execute with some result. And if you're not sure about which one is right, ChatGPT can't help you with that. But for typecasting, I think in general, AI is doing pretty well. You could use ChatGPT, Cloud Code, or Cursor, whatever. They should help with typecasting relatively well. Well, and similarly, they won't catch this type of error. They will say, okay, yeah, this is supposedly working. I don't know why it's not, because well, you might need to look into your SQL version, might need to look into your query engine, and so on and so forth. It's a mess. I agree. Okay, next topic we're going to introduce today is subquery and common expression table. Common expression table is actually not in the syllabus, but I think if we're doing subqueries, there's no reason we shouldn't do it. A subquery is basically a query inside another query. Basically, let's just go to this example. I want to select this thing from a table, but a lot of the results I want is not in the table directly. So what can I do? Well, I can just run this query here. This is basically the same thing as what I had earlier here, except I'm not selecting the mean price. I want to select all of the records where the maximum price is greater than 100, right? We're interested in a number of reviews only for the listing whose maximum price is greater than 100. Well, okay, this table, kind of, this query will give me a table where the minimum price is greater than 100. So yeah, the maximum price is greater than 100. And I am selecting from this table, right? And the rest of that is very similar to what we see earlier with the join command. I need to find the listing ID. And yeah, and this is exactly what I want. But this is what we call a subquery. You're selecting from something. Hold on, I could select from another query I run. And similarly, I could run select like something, 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 as long as it's one column here. It's totally fine. So you could have select query you can use subquery to get something more flexibly. That being said, I'm not a huge fan of subquery because it's kind of messy to read. What I really prefer is this thing called a common expression table. You're basically, okay, this is not my final results, yes, but I could still save it in one of the table, right? So how can I define that? Well, instead of writing a subquery and just telling with common expression table, this could be anything. This could be ABC, as long as it's kind of like naming a variable. This is my temporary table to store my results. I couldn't get information in one step, so I'm storing part of the results here in the CTD table, and then select, okay, I still need the listing ID, the the review count, but yeah, I only care about those where the maximum price is greater than 100. Then this is all of the records where the maximum price is greater than 100, right? So this is exactly what I'm doing now. I am selecting this table, creating this table to contain all the listing ID whose maximum price is greater than 100. Great. Now, instead of selecting from listing, I'm just selecting, okay, see the listing ID. These are the listing ID whose maximum price is definitely greater than 100. And then I'm counting their results. And the rest of that is similar to the first queries we have seen today, right? It's very similar to this one. This is the wrong one. Very similar to this one. So this is another way to run it. In principle, you could interchangeably use CTE and subquery. Personally, I would prefer CTE over subquery because it's more readable, and in many cases, it's more performant and more flexible. That being said, again, I believe in some SQL dialect, CTE is not available. Hold on a second. Let me find which dialect you're not allowed to use CTE. Let's see. Let's see. Is it MySQL? Okay, it's an older version of MySQL. I don't think you're supposed to work with older version of MySQL. That's old SQL version that's older than 20 years ago. Anyway, and you do have to be careful about CTE in some cases, but I think it's supported in 99% of the SQL version you're ever going to use. So personally, I prefer CTE over subqueries just because it's more readable. In principle, there's nothing stopping you from working with either of them. Okay, and this is where your SQL query could get really nasty. Unfortunately, the moment you have subquery and CTE, you're going to see like, yeah, it will take a while to get used to it. The best way to actually master these things is to practice how to work with them as much as possible. Okay. Any questions about CTE or subquery? It's really just creating, for my way of understanding CTE is really, you're just creating a temporary table to store the intermediate results before getting to your final results. And you could even do another CTE just with a comma and something, 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 and then run your final results by selecting stuff from it. Okay. So I believe you knowing how to write CTE or subquery will help you tremendously for this week's assignment. So please take a look into how to write it or how to work with it. Let's see. Okay, now we are moving into the next part before, unless anyone has specific questions. Okay. Now, the next topic we're introducing today is parameterized query and SQL injection. So what is the parameterized query? Is that, okay, instead of, I mean, so far we've been formatting SQL query as a string. But instead of formatting it as a string, we could just leave, okay, I want to filter based on condition, yes, but I don't really want to just format it as a string like here. I could take the input and output, but this is a terrible idea. I should just leave it as blank and work with this parameterized version. Why is that the case? What's the difference between leaving it a question mark and fill it later than just formatted it this way? Well, let's think about this example. If my input is ID, okay, I think I have a typo here. If my input is like this, let's see. Yes. I could potentially set my employee ID into this string, right? ID equals to 101 or 1 equals to 1. Semicolon, drop table employees. I mean, I'm not checking if this is a valid employee ID. So this will be passed into this query. What is the problem with it? ID equals 101 or 1 equals to 1. What do I get from this? It's an OR statement. This one is always true. So this one will always be executed, right? And what's the problem? The next thing will also be executed. So your table will be dropped, which means that your entire database is dropped. And your program is going to crash because someone, when they're entering their employee ID, just drop the entire table. This is a common problem with SQL injection. Similarly, I can run a select star from employees to hijack all of the employee informations you have in your database, right? This is another common usage of SQL injection. As a result, if you use parameterized query, this will not happen because, well, this will just give me an invalid query. I stopped. This dropped table will not be executed. Notice the difference? This is a common thing that a lot of developers are kind of lazy to fix to this date. That is why some of the hackers could get so much information you have from like those shopping websites. So, but in general, you could format a lot of the stuff with parameterized query. It doesn't have to be like only one of the things. You could have multiple parameterized query. For example, you could have multiple condition. No one ever says you can only have one condition in a where clause, right? You could join something like where this and let's say name equals to something. Again, this is a bad example. Or you can run and name equals to question mark and then let's say John. Ouch, I have a typo, but you get the idea. You could perfectly do this, and so on and so forth. So this will also give you a little bit more flexibility in your SQL query whenever you're running a question, well, a function in Python. So that's about parameterized query. Another way to stop SQL injection is basically, okay, have a check. Use like regex or whatever method you could to make sure what you enter is a valid parameter before passing it into your SQL. But that's whenever you're really exposing your like server or really maintaining a code base, this is something you should be thinking about, or at least keep in mind whenever you're maintaining something. Okay? All right. The next topic is a little bit more advanced. I'm a little bit surprised we're introducing it in Python 100, but I guess I could try to cover the basic of that. But there's a lot of you could do and a lot of confusion you could have with window function. So I guess I'm going to jump to date for now and come back to the window function. So as we have talked about earlier, SQLite has no built-in data type. It doesn't really have a date or a time column. Those stuff are stored in text. That being said, there are some functions that could take in a text and convert them into the datetime format we have. And there are for example, we have date, we have time, we have datetime, we have Julian date, we have S string for time, something, something, something. You can convert them into this type of format, and then a date plus hour, something, 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 or even more. You could also specify, okay, what is time zone you want, etc., etc. And some example is, okay, if you take a look into the listings data frame, listings table, you'll realize the scrape ID is actually the exact timestamp this listing data is scraped off from the internet. And this last scrape is, I would guess, is converted from this time frame here. So you could think about it as an exercise in your own time. How can I convert this into this in SQL or in pandas? I would assume this is the time, this is the hour, this is the minutes, and this is the seconds, so on and so forth. But on the other hand, another thing you could do is calling the Julian date, which will give you you may say, hold on, what is this date, Julian date? I think it's the number of days after like first common era, like for year 2000, this 2000 years plus the number of days that has passed since, well, since like the start of the common era, if that makes sense. And then we also have other functions like datetime. So if you have the datetime function will convert other string, for example, well, if I enter the datetime, I think this will give me a lot of time. All of them will be converted into the same date. Well, it's originally a date without a time. So what does the datetime function do? You would assume all of the time is 0, 0, 0, 0, 0. Makes sense, right? And also the time. Okay, if I run the time, then everyone will have the same time because I could pass in the time for this, and everyone will have the same time. We introduced this function just so you know, okay, these are some of the things you could use when you have to deal with the datetime format. Of course, it's not like exhaustive. I could also get like month, I believe. Oh, month is not a supported one here. Hold on. Can I do this? No, this is only for PostgreSQL. So if I want to do this, I think I need to do date trunc, and then month. Yes. It's not. Something like this. Oh, it's not the right. Trunc supports the following for the date part. Yeah. Confused. Hold on. Anyway, this is supposedly working. Date expression, date part. Yeah. Date part. This first one and the second one. No such. That's scraped. Can you see why this is not working? Something like this. Hold on. Anyway, working with string function is datetime in string function is a huge mess in general. Let me try to fix this a little Let me take a look into the documentation. Let's see. Okay, that's because this function is only available in Postgre, not SQLite. Huh. Okay, so I think the only way I could do this is this. Get the year and the months, and then the last script. Yes. Okay, this works. As a side note, the function I was trying to call date trunc, this works in Postgre, but not in SQLite. Sorry for the confusion. I'm more used to working with Postgre. But anyway, there are a couple different ways you could do it. You may want to ask, okay, why would I ever be interested in doing so? I mean, you could run so that well, there's no built-in month column or date column, right? One way you could do is, well, what if I want to know the average price of the listing based on the month or the day or day of week? This is when you might need to work with extract specific component of the date and then run your group by based on those scenarios. So these are something with them. Feel free to play around with them. Personally, I would never say I'm 100% confident with them. Okay, another thing we could work on with SQL is something that's called, well, actually, it's a very common operation, but it's confusing to start with. It's a window function. A window function performs calculation across a set of table rows that are related to the current row without collapsing rows like group by. What does that mean? Okay, let's select everything from limit 5, actually limit 10. Oh, sorry, I don't want listing, I want calendar. Right? I have this calendar table, and previously I have calculated the maximum price and minimum price for each of these listings. I know I have 3,800 rows for that. And now, what if I want to know, okay, relatively speaking, is my price expensive or not? I want to know, okay, for each listing, what is the most expensive listing, what is the cheapest listing, and what is everything in between? How could I do that? I mean, I could run this, but I don't want to change the number of rows I have, right? This listing appeared like a dozen times, and I want to know every possible price I could get. What can I do with it? Well, this is when you could start using window function. So here I have the listing ID, I have the price, I have the maximum of the price. I'm still doing the casting here, but this is just telling SQL I need the maximum of the price over, what does this over mean? Over is specifying which windows I'm using. Partition by listing ID. That means I'm kind of doing a group by listing ID, but I'm not collapsing my records into one single row. On the like behind the hook, like below the table, SQL is going to kind of run the group by operation without collapsing everything into the table. So I will still get the maximum price for this one, but this time for every single row. And similarly, well, I'm not sure disable the distinct here. For every single row, I got the maximum price. And I also got their current price. And so we got the listing ID, the current price, the maximum price, and now I'm creating another variable called price rank. I'm telling it, okay, I want to rank over all the existing price for this specific listing. This is what we call a window function. Here, okay, I have 365 rows. Let's just select the distinct row, which means that I'm only getting the distinct pricing. It seems like, okay, other than none, I have this property has been listed at 125, 110, and $99 before. Another application I could use for window function is that I could try to calculate the what is the value 2 rows above and 2 rows below. So far for aggregating functions, what we've been doing is that, okay, we've been trying to aggregate based on one of the rows and collapse everything into one number. But here with window function, we could actually get those numbers without collapsing them. That being said, there are a lot of the things you need to be careful about syntax here. For the group by, you're not running group by in window function, you're calling it partition by, and so on and so forth. I think in the original materials, this is briefly covered, but not covered a lot, simply because first, different SQL version has kind of a little bit different usage of that. Second, it's just difficult to write to start with. So take a look into some of the SQL instructions you could find online. But yeah, this is a kind of an advanced topic, I think. If you have time, take a look into it. If not, forget about it for now, I would say. It is useful, it is common in SQL, but it is something that may take a little bit of time to actually get used to. Okay, I think that's all of the materials I have for today. And there are a lot of other stuff you can fit into the window function. You could do a lag lead operation to calculate the moving average. Anything you could run in group by could be passed into your window function. For example, I could calculate how many times this 110 appear up here, something like this. And a lot of the window function operations are not necessary because, well, given that they are created by group by, you can run a group by and then join them back with this table. So there's always more than one way to do the same problem. You could run, instead of using window function, you could run subquery, you could run the common expression table. And some of you might still think it's easier to run it with like window function. That's totally fine. But be cautious when you're running window function, especially when you're not completely familiar with SQL. I would say read into them, read into window function. If you have time, go find some practice online. I think there are some exercise to just help you master like window function. Otherwise, I was really focused on the basic of aggregation. Make sure you know how to write group by and know join is a lot more important than knowing how to run a window function at this point. Okay, I think that's all of the materials for today. So I'll hang here for a few more minutes. Feel free to stay if you have any additional questions from this session or about the assignment in general or about SQL or Python. And otherwise, I think that's all for today. Thanks for coming. Stop recording and then see. Right, thanks for coming. Feel free to stop by if you have any specific questions. And I mean, you could also book my personal session if you want.